Here's an example graph f of x where it's x plus 4 if x is less than or equal to -2 and -2x if x is greater than -2. So it helps, this is basically saying use y equals x plus 4 for numbers -2 or less. Use y equals -2x for numbers greater than -2. So again, it's helpful if you remember what the basic shape looks like. The first one is going to be a line, right? It's going to be like up 4. So it's going to look something like that, but it's only going to be for values -2 and to the left of it, since it's less than, x is less than or equal to -2. For y equals -2x, right, that is a line with a negative slope, so it's going to look something like that, but that's going to be for where it's greater than -2. So to the right of -2, you're going to see that little graph there. Okay, so let's go ahead and graph this. It says y equals x plus 4 for numbers that are -2 or less than that. So I'm going to go ahead and plug in points. So for that one, I'm going to go ahead and you always start with whatever that number you see is there. So I'm going to plug in -2. So if I plug in -2 to x plus 4, I get -2 plus 4, which gives me +2. So -2 comma 2 is right here. And because it's inclusive, right, it's less than or equal to, I'm going to use a closed dot. And notice that I am going to the left because it says I want to use values that are less than or equal to -2. So we're going to the left of the number line if you think in terms of the x direction. So what's the number to the left of -2? So you can pick like -3 or -4. I'll just go ahead and pick -4 here. What's -4 plus 4, right? Because that's the rule. You get out 0. So at -4, you get out 0. And you're going to go ahead and just put a point there. So now I'm going to connect the dots and I'm going to go just to the left, right? Again, my graph only exists where x is -2 or less, right? So it's -2 or less. So to the left of it is my graph. And that's what I was expecting because I have a positive slope graph, but my graph exists only where x is less than or equal to -2. So at -2 and to the left of it. Now let's take a look at the graph for when x is greater than -2. So I'm going to make a little table again. Even though it's greater than and not equal to, I still start plugging in the values at -2. Okay, so you always do that. So if I plug in -2, -2 times -2 gives me +4. So at -2, I'm going up to +4. 1, 2, 3, 4. But since x is greater than -2 at that location, I'm going to have an open circle. Okay, open circle because it's not inclusive of that location. This border point here, right, -2 is the only location where you will have one point that is closed or like circled in, right? And then one that is open circle or exclusive. Like everywhere else, it's going to be like normal dots, normal points. Okay, so since I am going to the right, because I'm going for x values that are greater than -2, greater than -2, let's just pick another point. I don't know if I plug in 0. What's -2 times 0? I get out 0. So 0, 0 is a point, and I'm going to the right. So here is my graph. Okay, so again, this is what I was expecting. I was expecting a line, right? Because y equals -2x is a line. But I only include the part of the graph where your x value is greater than -2. So again, -2 and greater. Right, so sometimes students want to start from like -1, but then you would miss out on all these points here, right? All the points between -2 and -1. So make sure you, again, start from whatever value you see here. If it's greater than or less than, make it an open circle. If it's less than or equal to or greater than or equal to, include that point, so by closing it in or coloring it in. Okay, here's another example. Graph f of x equals x squared minus 3 if x is less than or equal to 1, and f of x equals 5 if x is greater than 1. So again, it helps if you remember that x squared minus 3, that's just a down 3 parabola. We're going to have something that looks like that, but only for x values 1 or less. And then y equals 5, that's just a horizontal line, right, going through 5. But again, it's only going to be for that portion where x value is 1 or greater than 1. So let's go ahead and do this. For the first one, okay, again, I'm expecting a parabola. I'm going to start with a point 1. If I plug in 1 here, 1 squared minus 3 gives me negative 2. And it's going to be closed point because it's inclusive. So 1, negative 2 goes right here. If I plug in 0, I get out negative 3. Okay, so here's where you have to be careful. If you did not remember what the basic shape looked like, right, if you didn't remember that this was a parabola, you would just draw a line. You're like, okay, I have another point, so I'm just going to draw a line. But that would be incorrect because this is not a line, it's a parabola. So that's why it's important that you remember what the parent function looks like and what basic type of sketch you're going to get. So I'm going to go ahead and plug in another point. Note that you could like reflect it over if you wanted to. I'm just going to go ahead and plug in, let's say, negative 2. If I plug negative 2, what would I get? Negative 2 quantity squared, that's 4 minus 3 gives me 1. So negative 2 comma 1. I would have that graph. Again, I can reflect this point over here. And I would have a parabola. Again, I'm going to the left of 1. That's why I connect my line to the left of 1, right, and not to the right of it. And then you have an arrow going to the left. Now looking at the second equation here, we have y equals 5 for values where x is greater than 1. So that means we don't really need to make a table here, but I'll go ahead and do that. When x is greater than 1, you get 5. Again, always include that value, even if it's exclusive, so we can mark the borderline. So at 1, you would get 1, 2, 3, 4, 5, right? But it's going to be an open circle. And then when it's 2, it's 5. When it's 3, it's 5, right? It's just a horizontal line going this way. So that is your final graph. Note that where the break happens, right? Where the break happens, right, at 1 in this case, one of them will have a colored in dot, a closed point. The other one will have an open dot, an open point here. One will go to the left and one will go to the right. This is still a function, so you should still be passing the vertical line test, meaning if you were to pass a vertical line, if you were to move a vertical line through, here from left to right, right, you would have an intersection at most at one location, right? For every input, there's exactly one output, so you would have to pass the vertical line test. Here's another example graph. F of x equals negative x minus 2. Notice that this is a negative slope graph, right? You're going down 2, down 1 over 1, so it's going to look something like this, but only when it's 1 or to the left of it. And then we have 2 to the x minus 4 if x is greater than 1. So that graph is going to be down 4, right? But it's an exponential graph, so it's going to look something like this. But again, we're only going to have the graph to the right of 1. So let's go ahead and make it a little table. For that first graph here, let's go ahead and again plug in 1. Negative 1 minus 2 gives me negative 3, and it's going to be closed point. Since it's equal to 1, negative 3, it's going to be closed point. And I'm going to the left of it. Notice you could also use the slope here, right? Because this is a negative 1. It's a down 1 over 1, so you can go up 1 over 1 reverse directions. You can go that way, right? Or if you weren't sure, you can just plug in a point. If I plug in 0, 0 minus 2 is negative 2. Or if I plug in negative 1, negative 1, that's positive 1 minus 2 gives me negative 1. Right, do you see that? So you basically just get a line, and you only have the line going to the left. Again, we have this line here, but we're only including the portion of the graph where your x values are 1 or less. So 1 or less. Let's take a look at the second one. We have 2 to the x minus 4 if x is greater than 1. So again, I'm going to start with that breaking value, so 1. So 2 to the 1 is 2. 2 minus 4 gives me negative 2. So at 1, I get negative 2, but it's greater than. So at 1, negative 2, I'm going to have an open circle there. Okay, so I have an open circle there. And then I'm going to plug in values greater than 1. So let's say if I plug in 2, 2 squared is 4. 4 minus 4 gives me 0. So 2 comma 0. plug in another one. If I plug in 3, 2 cubed is 8. 8 minus 4 gives me 4, so 3 comma 4. 2, 3, 4. And then I'm going to go ahead and connect it. Right? So I hope you can see, like you can imagine, there's a, what is it? Horizontal asymptote to the left of it, so that's why I don't need to graph it in, since the asymptote would be here at down 4, right? And then you would normally have an exponential function, like exponential growth here, but because I'm only interested in values, or because I'm only putting values 1 or greater, right, this is the portion of the graph that I would have, and that is your final answer. Okay, let's take a look at this last example. Evaluate, meaning find the value for this f of x function. So we have a piecewise function here, and we have 3 different pieces. So evaluate the function when x equals -3. So when x equals -3, that means if your input is -3, what would your output be? So again, you look at the domain first. So look at the domain and see which rule you're going to use. You only get one answer for your for the problem here. You should only get one output, right? Because it's a function. For every input, there is exactly one output, right? So you're only going to get one output. Sometimes students give me like 3 separate answers, plugging into all 3 of these, but you don't do that. You only plug into one of them. So where does -3 go to, right? -3 goes right here, because -3 is a number less than or equal to -3. So you're going to use this rule here. So 2 to the -3 plus 1. Well, 2 to the -3 is 1 over 2/3, which is 1 over 8. So that's 1 and 1/8. So 1 and 1/8 or 9/8, either one is fine, is your final answer. When you plug in -3, you get out 1 and 1/8. Let's go ahead and try it for x equals 1. Which rule are you going to use? Right, you're going to use the second one here, because when you look at the domain, 1 fits right here, so this is the rule that you're going to use. So f of 1, that means if your input is 1, you're going to use the rule -5 times x, but your input is 1. So your output is -5 times 1, which is -5. What about when you have an input of 4? If you have an input of 4, what will you get? You'll use that third rule here, because 4 is a number greater than 1, therefore we're going to use this rule here. So log base 2 of your input, in this case, is 4. So let's ask ourselves, 2 to the what power gives you 4? 2, right? So your final answer is 2. Last one, when x equals 0, what is your output? So when your input is 0, what is f of 0 going to be? Which rule will you use? Okay, you're going to use the second rule here, because 0, right? 0 is a number between -3 and 1. So -5 times 0 gives you 0, and 0 is your final answer.